Starting with section 1, main idea, like I said, this is a little bit digging into the history of atoms. Atoms are very, very small. We finally now have microscopes that can pick up outlines of atoms, but for many, many years, because they are so small, they were very hard to study. And even seeing, contemplating what's inside is still very hard to study. So the ancient Greeks were kind of the first ones that tried to explain matter. However, they didn't really study a whole lot about atoms until John Dalton was the first one in the early 1800s. So quite, scientifically even, that's quite a while ago. Essential questions. And this is what I want you to know. Democritus, what was his model like? Aristotle, what was his model like? Dalton, what was his model like? And then Dalton's theory is going to be related to our conservation of mass. So he studied that a little bit further. Vocab, like I said, short section, not a lot of vocab. So, starting way in the back, a lot of ancient scholars believe that matter was classified as earth, water, air, and fire. So that's how they grouped everything. So earth, water, air, fire. Where do birds go? Yeah. Air, earth, they live in a tree, they fly. So a lot of the things that we talk about couldn't fit into those 4 categories. So obviously that has changed. Many believe that you could take matter, so matter being anything that's made up of particles, that matter could be endlessly divided into smaller and smaller and smaller and smaller pieces, basically until you had almost nothing. So, first person, Democritus, which I'm guessing maybe you've at least heard his name before. So BC, before Christ, this is not 1800s, this is a very long time ago, was the first person to even introduce anything. So he proposed the idea that matter was not divisible, that you couldn't keep dividing it forever and forever. But it was made up of little particles called atomos, and that's where the term atom comes from. So Democritus basically came up with atom. Atom is something that is small and can't be divided. Aristotle, about that same time, disagreed with Democritus because he did not believe that there was empty space. So, here you have 2 scientists during the same time period that did not agree on something. How come one couldn't prove the other one wrong? They couldn't see it. It was not something they could not prove their point because they couldn't see it or show it. It was a theory that they had. So Aristotle, his views went unchallenged for 2,000 years simply because we couldn't test it. We couldn't look at it and we couldn't test it. There was no way of proving anything. So for 2,000 years, everybody thought that Aristotle was probably right. And here, this table is in your book. This kind of shows the things that the ideas that each one of them had. Democritus, matter is composed of atoms, which move through empty space. Atoms are solid. I can't break down an atom. Different kinds of atoms have different shapes, la-da-da. Aristotle, empty space cannot exist, and matter is made of earth, fire, air, and water. So, for 2,000 years, people agreed with Aristotle. Looking at this table, who's probably closer to right? Democritus. Not that he's perfectly right, but probably closer to the truth. Then, so here, like I said, 2,000 years later, approximately, early 1800s, John Dalton finally starts doing some real testing. So Dalton's atomic theory, this you should know, maybe X this. Dalton's atomic theory explained conservation of mass. Mass cannot be created, it can't be destroyed. And as a result, these atoms are combined, they're separated, they're rearranged. They're not just magically brought about. So, Dalton's theory, matter is composed of extremely particles called atoms. Still true today. Atoms are indivisible and indestructible. Not totally true today. Atoms of a given element are identical in size, mass, and chemical properties, for the most part. Atoms of a specific element are different than another element. That's completely true. Different atoms combine in whole number ratios to form compounds. That's completely true. In a chemical reaction, atoms are separated, combined, or rearranged. So, by the 1800s, we have a very good idea about atoms. We've done better, we've found more out, and we've kind of tweaked some of these things a little bit. But Dalton's atomic theory, for being a very long time ago, was pretty spot on, especially for that time period. So, Democritus, Aristotle, the earth, wind, and fire. Dalton has the list of his atomic theory. If you look in your book, as far as atomic models go, we're going to get more into actual pictures and diagrams that scientists came up. These were more kind of theories than actual diagrams. And then Dalton's theory said that atoms are rearranged. They are not created, they are not destroyed, and that's why whatever we start with, we have to end with. And that is pretty much it for section 1.